Today we're going to talk about how to solve trigonometric equations. So I have 2 cosine of theta minus the square root of 3 equals 0. The cosine of theta is my variable. That's what I'm going to try to get by itself. So in order to do that, I have to add the square root of 3 over. So I get 2 cosine of theta equals the square root of 3. And that 2 is attached to that cosine of theta, so I have to divide it over so that I have cosine of theta equals the square root of 3 over 2. And then from there, I just look on my unit circle, and that is true at pi over 6 and 11 pi over 6. Let's do another one. Over here we have 4 tangent of theta equals 3 plus the tangent of theta. Again, my tangent of theta is going to be my variable. So I basically have 4x equals 3 plus 1x. To get all the x's on one side, I have to subtract that x over. So I'm going to subtract the tangent of theta over. When you do that, you get 3 tangent of theta, and that equals 3. To get tangent of theta by itself, I'll divide by 3. So tangent of theta is 1, and then you just go to your unit circle, and the tangent of theta is 1 at pi over 4 and 5 pi over 4. We'll do some different ones using some different identities and formulas. So over here, we have the cosine of pi over 2 minus theta equals the cosecant of theta. Now when I see pi over 2 minus theta, I know I'm going to use a cofunction formula. So if you go to your sheet and you look at cofunctions, the cosine of pi over 2 minus theta is the same as the sine. So I'm going to change the cosine of pi over 2 minus theta to sine. So when I change that sine there, I also change the cosecant to 1 over sine, because again, it's always good to have things in terms of sine and cosine, if possible. Now this sine of theta is over 1, so I can cross multiply and end up with sine squared theta equals 1. Now again, this is like having an x squared equals 1. If I want to get rid of the term that's squared, you have to square root it. When I square root it, I get a plus or minus 1. So I'm looking for where the sine of theta equals a positive and a negative 1. And that's going to be true at pi over 2 and 3 pi over 2. Now this one here, we have sine of pi over 2 minus theta equals negative cosine of negative theta. Again, that pi over 2 minus theta tells me that I'm going to be using the cofunction formula. So looking at my cofunction, the sine of pi over 2 minus theta is cosine of theta, and that's going to equal the negative cosine of negative theta. Now when I see that negative theta, I know I have an even or odd function. So looking at my even or odd formulas, the cosine of a negative angle is just the positive cosine of that angle. Again, the cosine of that negative angle is a positive cosine of the angle. So I'm going to change this cosine of negative theta to a cosine of theta. This negative is still here because this negative was on the outside. So I wasn't messing with the negative on the outside. I was only messing with the cosine of the negative theta, which is a positive cosine theta, and then tack on the negative theta, or the negative on the outside. Now I have cosine equals negative cosine. Well, it is never true that the cosine of an angle is going to equal the negative cosine of that same angle. So we put no solution. We'll do one more. The tangent of pi over 2 minus theta plus the tangent of negative theta. Again, I see pi over 2 minus theta, so if I go to my cofunction, I'll see what the tangent of pi over 2 minus theta is equal to, which is the cotangent. And then I have tangent of negative theta. Again, I have that negative angle, so I have to use my even and odd function formulas. And it turns out that the tangent of a negative theta is equal to the negative tangent of that angle. So I change that tangent of pi over 2 minus theta to cotangent using the cofunction formulas. And then the tangent of negative theta changes to a negative tangent of theta using my even and odd formula functions. And then what I do is I add that tangent of theta over, so I have cotangent of theta equals tangent of theta. Now if I wanted to, I could change to sine and cosine, but that turns into a big mess and it doesn't work. And so I just have cotangent of theta equals tangent of theta, so I just look on my unit circle and find where the cotangent equals a tangent. which is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. If you want to, you can change the cotangent of theta to 1 over tangent, and then cross multiply and take the square root and do all that stuff, but I think it's just easier to just have cotangent equals tangent. So again, with all these different identities, there's lots of different ways to do these problems. You just have to make sure you use them correctly, and you'll end up with the right answer.